Hello and welcome to the Automotive podcast. This week we'll be talking with Jove, our reliability engineer, about his journey with Automotive and his mission for sustainability. Thanks for tuning in.
Hello, welcome to the show. Today we have with us Jove. Would you want to take a minute and introduce yourself?
Yeah, my name's Jove. I'm a reliability engineer at Automotive. I've been here 7 years, and I've done a lot of different roles. I'm a mechanical engineer by training and worked in the initial design team on the Gen 8 for a couple of years, and then as the company grew, I moved into several other roles between then and now.
Beautiful. And so reliability engineer, what does that encompass? What's your day-to-day look like? What's the goal of your work?
Basically to improve the reliability of Automotive vehicles. That includes looking at any issues we're having and how to solve them. Also looking at any designs we're working on and how we're going to test those. So then I tell the designers, okay, this is going to have to go through this amount of vibration, this amount of salt spray, this type of electrical immunity testing. And that just depends on the...
Life isn't in a lab with no dust or anything in it. You got to actually create a vehicle that people can take out.
Right. And if a component's going to be, up in the dash, maybe it doesn't need to be as immune as something down on the fender that's going to get road spray and salt and pressure washed and that type of thing.
Yeah. And when you were becoming a mechanical engineer, did you figure that you'd be in this path, or did, after a while of working at Automotive designing, did you say, wow, I really like making sure that this is the most reliable machine it can be?
Yeah, definitely a progression. When I was younger, my passion was design, and my first, 6 or 8 years in working as a mechanical engineer was all design work, and then a little bit of management, group management, design group. So my passion was in design, and then as this product has gone out into the world, and I've, the first person to get called when something isn't working right is the person who designed it, or the person who was around at the time it was designed by somebody else. And then, so I started doing more and more problem solving. I did some quality engineering with my previous job. That was a product that was made in China, so we'd go and do the quality control there. But then we'd have the issues here.
As in you worked in China? You lived and worked there?
No, I worked and lived in Eugene, but the product we were selling was manufactured for us in China, my previous job. Beautiful. So that was my grounding in quality and problem solving for reliability.
Cool. So moving from there to Automotive, how did you meet either Mark or the company, and what kind of brought you over to the team?
I have always been interested in, since I was a little kid, right, is knife making, right? I can remember being 5 years old, and in my dad's workshop, he was a candle maker, and he was a sociologist who dropped out and became a candle maker. But I would just hang around while he was working, and I was sharpening this butter knife on this concrete wall, because I had the basic principle, you got to wear it down till it's thinner, right? So when I moved to Eugene, I found there's a little knife makers show and tell group where these old guys usually will be like, hey, I made this, or hey, I have a problem with this. What do you think of that? And I started going, and I started learning knife making and setting up my own home shop. And I met Jim Jordan at the knife group. And we became friends, and I'd occasionally come into Automotive. I actually met Terry and came into the office through Terry.
Terry Becker,
yeah.
The COO.
Yeah. And then stayed in touch with Jim Jordan after that, and then when they came into a little more funding at the beginning of the Gen 8 program, they're like, hey, we need another mechanical engineer. I got a call.
And so you started with actual designing of the vehicle, of the SRK, was it at that point?
It was the Gen 8 SRK. That was right when we went from the steering wheel to the handlebars, and we made the vehicle. In that first 6 months, we designed the first, we called it the mule. It was basically no body work, just essentials. Almost every piece of the vehicle was a one-off build. The gearbox was actually machined on a manual mill by a guy we found to do that for us.
And so back then, what was the purpose of making one-off prototypes? Was it to show to people as hey, here's what it'll eventually kind of be like, or?
That came next. What came first was where are we going to put everything? Where's the center of gravity going to be? Is it going to be stable? Is it going to have the performance we expect? So it was a case of how quickly can we get all those answers? And the quickest way because you can do your simulation and your mathematics forever and not be completely sure that it's right. And the bigger the problem is, the more complex the problem is, the more time and checking it takes to be sure that your math is right. But if you build it in reality, you know for sure what the stopping distance is, what the stability is like, what the acceleration is like. So we just went hell for leather, design it and build it as quickly as you can. And in 5 months, we went from our basically a sketch in CAD to that first mule and doing stability testing and initial brake testing.
Wow. And were you actually like feet on the ground, kind of like welding it and putting it together? Or were you more of designing the CAD model?
I came in for design of suspension and brakes. That was my initial mandate when I came in the first few months. And within a couple months, I was having these conversations with Mark, like, why are we doing it this way? Why are we organizing our CAD that way? This is making it hard for everybody. And he's like, I'm out of town a lot looking for funding.
Yeah.
Do you want to be the guy who knows what's happening when I come back into town and just like organize what's happening on the design floor? So I did that and I kept designing. Of course, it's hard to do both, so I did less designing after that change. And we hired a few more engineers. And we had a team of maybe 10 or 12 designing, including electrical design, mechanical designers, and builder shop guys who were fabricating parts or making models.
And at this point, you're moving away from brakes and suspension, or you're still mostly focused on that? What's something about the brakes and suspension of the FUV that you like really think is awesome or cool, or like maybe you had to change like from disc brakes to, like, I'm curious, is there any part of the FUV suspension and brakes that you're like, this is a really cool piece of technology that you're happy got implemented?
The double wishbone suspension is a really nice feature. A lot of small performance vehicles like the Miata has that type of double A-arm suspension that we have. I think it's aesthetically good. I think it's good from a performance perspective. With suspension, you always want to get the mass away from the wheels so they call that unsprung mass, right? Weight that's attached to the wheels and the knuckles is unsprung. So when you hit a pothole, that gets thrown up in the air and then it bounces down and bounces on the asphalt. And your shock absorber has to absorb all that energy. So the lighter your wheels are, the less energy you have to absorb and the less it knocks your whole vehicle around. And the quicker you can get back on track and level.
Yeah. So that's nice for, like, the Automotive has kind of small wheels compared to, like, it doesn't have like 22-inch
Right, they're
wheels.
15-inch wheels.
So 15 inch is significantly easier and better for shocks. And
Right.
very cool.
Yeah.
I like it. And so now, do you still kind of focus on brakes and suspension, or now you're in the entire vehicle making sure the quality of it's the best it can be?
Yeah, these days most of my work is around the reliability of electrical system stuff, just because that's where we're finding the most room for improvement and more testing and that type of thing.
So software, because I'm aware that there's software updates that can be made to, you buy an FUV and then if a change gets made, instead of having to you bought the outdated model, it's like you can just get an update to it. Are you dealing with a lot of software improvements?
No.
Actually welding the cables together?
It's more like
soldering.
If you had a let's say headlamp, right? And it is positioned in such a way that it gets a lot of road spray on it. And maybe you're having issues with some customers are getting fogging inside the headlights. We've all seen that on a car, right? Where the headlight unit is not fully sealed. And then it's getting some moisture in there that's circulating and fogging it up. And then the customer complains, like, how can we make sure, let's say we're like, these headlights just aren't that good. Our headlights are fine.
Yeah, we're not talking about
just an
FUVs.
example.
We're talking about like a Honda Civic or who knows what. Like,
but if you were going to say, okay, we're going to implement a new headlight because we think that's the best plan, how do you ensure that next headlight is not going to have the same problem or a different problem?
Yeah.
Right? And if you're going to order enough for thousands of vehicles, and maybe you're going to pay, 10 to 50 grand in tooling to have the light made the right shape to fit your vehicle from a different manufacturer who you trust more, how can you be sure it's going to work? Are you going to have the same problem or a different problem?
Yeah.
And that would be like, like IP rating on electronics, right?
Mm-hmm.
They say like, oh, it's, this watch is submergible to whatever. And
35 feet for 30 minutes.
Right. So that would be an example of a piece of testing specification. Mm. So you tell the designer, and the designer's like, oh, I better make the case a little thicker if it's going down to 35 meters.
Mm.
That's...
Luckily, FUVs aren't meant to be submergible.
Right.
Right. A whole,
but you might use some of that same testing on the headlight if you want to be really sure that there's no water getting in.
Absolutely. And so you just order one at first and like really throw it through the ringer and make sure it's good. And then you order the, thousands or...
So that would be what they call a pre-production sample. So the manufacturer, usually there'll be some sort of purchase agreement where it's like, yes, we'll buy them. They look good, but it has to pass this list of testing. And the manufacturer will say, yep, I think we can pass all of that, and we'll send you the things. Or they'll say, no, we're not going to sign up for that testing because our products usually don't pass that. Adjust it. Like, there has to be an agreement, right?
Absolutely. And so you're involved in the FUV and the MLM. Mm-hmm. And what was it different, kind of working on a full-on vehicle versus a micromobility vehicle? I mean, the MLMs, the battery's exposed to rain and stuff.
Yeah, so you got different exposure requirements and different vibration requirements and different lifespan requirements. Like, in terms of vibration, people aren't going to ride their bike for 15, 20,000 miles a year, right? Whereas people take their average car and they will drive it those kind of distances because it goes faster, it's more comfortable, you can do it for more time before you're just like, this is too exhausting or whatever, right?
Yeah.
So like if you look at e-bikes and other vehicles in that size range or like motor scooters, right? Because the MLM can kind of fill that niche between small motorcycles and e-bikes.
Yeah.
Use case wise. And maybe broaden that space as well. So you want your testing to be in that realm, right? Because you don't want to put more material in there than the customer is going to use.
Yeah.
Like if I gold plated the back of your iPhone and it's like, it's going to last 1,000 years, you're like, but it costs $3,000. This is stupid. Yeah. Right? Give me a piece of aluminum or hard plastic that gets the job done. Yeah. And so what you're trying to give the customer is the value they need and not a load of extra value that's pointless, but also not under design it so that it doesn't get the job done for the design lifespan, right?
Absolutely. And so example of that, you mentioned vibration. So vibration is really bad for batteries, and with the FUV, the battery's in the actual vehicle, not in the wheels, but the MLM, the battery is in the wheels. So how do you account for the wheels probably vibrate a lot more than the actual chassis of the vehicle.
I think the motors are in the wheels.
The motors and the wheels, yeah. My bad.
So those motors will have to tolerate a lot more vibration than the FUV motors, which are isolated in the middle of the chassis and kind of protected by the chassis and the suspension.
That's what it is. I kind of added them two together.
But no, it's very, it's a good point.
Yeah, and so do you take the vehicle first gets made and you just take it and you just absolutely ride it to the end, ride it through big puddles? Like, are you the person who tests it, or do you have someone else like, hey, go ride it around for 10,000 hours for me and report back?
Both.
Oh, wow.
It depends what you're doing. Like, so if we've got a really big test, then we will contract with a company to run that vehicle for months, and they will, say, provide the test track and the driver and the reporting. Because some of the test tracks for something like a FUV are acres and acres, right? And they're going to drive it 24/7, except when it's charging. Mm-hmm. And I mean, we could do that. We could get a field and make a test track and hire the guys and stuff like that. But it just makes a lot more sense to have the people who do it every day do it. Or if we're doing like a big corrosion test, pay the people who have the big corrosion chamber already and do this all the time. And then if we have more simple testing or stuff where we want more information, when possible, it's great to have tests that the designers can actually see their parts fail, because it's just so much more tangible. And then they go back and they're like, okay, I know what is wrong, rather than just getting a failed report. You know, it's like school, right? You get the essay and they're like, this wasn't a very good essay. And you're like, but why?
Yeah, absolutely. So there's a company. So if you own an electric vehicle company, you have to pay another company to take one of your vehicles and put it in a corrosion room. So it's like salt water in the air, or like they just try to corrode your vehicle as quickly as possible.
Yeah.
Wow. With realistic conditions, they're not going to put battery acid, on it or anything. They're going to just be like, hey, here's like if you live on the coast, you may experience a lot more salt.
Yeah. So that would be like the way you design your lifespan test. And that's a back and forth with them. We can say, hey, what's typical, right? What type of schedules do you guys run regularly? And equally, we can say, we'd like to add this aspect to it, or we'd like this test to run longer, or we'd like a report at 300 hours, so that would be a report. But we also want you to run it till it fails, or up to 1,000 hours.
Yeah.
So.
And these are all different so how many different kind of people, and you may not have the number in your head, like one person does corrosion, another person has a big multi-acre field that they just drive around constantly. Like, are there like a dozen of these different things where you're like, you test this, you test this, you test this, and then they all you get report cards for each one, or?
Yes, some test houses will run, let's say this test house runs 30 different types of tests, and this runs like a different 30 types of testing, and they overlap on 10 of them. Mm-hmm. So then you can like send a vehicle to these guys and say, hey, I want you to run this test, and this test.
Yeah.
And then some tests are incompatible, so you can't like do a bunch of corrosion testing on a vehicle that's gonna, try to think of a good example.
Be riding around a field the whole time.
But equally, you can make them sequential, right? If you've got the time, you can say, hey, I want this to do corrosion testing for a month, and then I want it to be on the track for a month.
Wow.
That's up to us, right? We get to decide how we're scheduling those.
That's fascinating. So that's why, in the big scheme of things, like Arcimoto's still in the early stages of being a car company, because being
right.
a car company is holy cow.
Right.
And I mean, compared to like any other consumer item,
right,
it's massive.
If we go back to like our beta vehicles 2 or 3 years ago, we built a batch of them and did a lot of testing, and also like consumer testing and stuff like that. And that maybe was like, was it 20 vehicles or something? Mm-hmm. But if you were a large car company, you might do 80 vehicles per like different types of testing.
Wow.
Right. And there's also component testing.
So you have to make
like
80 vehicles you're never going to sell.
Testing.
80 vehicles just for testing, pretty much.
Oh, they make hundreds.
Wow.
Yeah. So it's...
My mind's blown. Yeah. I didn't know any of this.
I had no idea.
Super surprised.
Yeah.
Wow.
There was a time when I didn't know any of this either, but like, if you're looking at it's all about how much of something you're going to make, mm-hmm. right? If you're going to make 1 million of something, then you want to be really sure that it doesn't fail early and you have to pay the customer back. Mm-hmm. And you're willing to burn 100 or 200 or 500 of those to make sure that the 1 million of them are really certainly going to pass their lifespan.
That makes sense.
Right? So if you're going to make a Toyota Corolla and you're going to produce one every like minute for the next decade, you better be really sure that every component's going to last. Otherwise, you're going to pay for it. Because when you sell a vehicle, you basically make a contract with a customer, right? That's your warranty.
Yep.
It's like, this is not going to have any problems in the first 3 years, and it's not going to have major problems in 10 years.
Yeah.
And if it does, I'll pay you back.
That's crazy.
So you better do your testing.
Yeah. And so that's wild. And so that's what happens when a car manufacturer has a recall, is that they didn't test it well enough and they started just manufacturing that million? Or like, what would happen because I mean, you hear about it, all these different car companies, like, oh, this one's airbags didn't work. And it's like, mm-hmm. did they not test it well enough? Or is like, what would happen?
Yeah, so the airbags one is something everybody knows about. That was really public and fairly recent. But like, recalls like that are happening.
Wait, what car company had airbags? That I actually was just making something up.
Oh, Honda, this is in the past 5 years, had a recall for Takata airbags. Takata was the company that made the airbags for a number of Honda vehicles. And then they had an issue where the clips that hold the bag in, I'm super paraphrasing, mm-hmm. I'm sure there's loads of detail online, but my basic understanding is the clips that hold the bag in corroded or fatigued or were too brittle or something like that, so that when the airbag went off, it fired the metal clips at you too.
Oh, wow.
So it wasn't a very safe airbag.
Yeah. It's funny. You say everyone knows about it, but people in your world probably do know a lot about it, but I had no idea. I was just like, airbags is something that can go wrong in a vehicle.
Yeah. So if you've got hundreds of car companies, mm-hmm. and you've got hundreds of airbag companies, and each company makes multiple different airbags, and then over the years they're all changing their stuff, right? They're like, the guys who work on the airbags, like, we can make these clips a little better, we can make the housing a little better, and the car company's like, yeah, that's fine, it just has to pass testing again, and we can integrate it into our production line of Honda Civics. Then 10 years go by, and a few of these things, blow up incorrectly, and then Takata's like, that's not our airbag, and then after a while they're like, yeah, it actually is our airbag, sorry guys, we'll pay for the replacement of the airbags, which is mainly the cost of paying service guys to take it out and put one in. The airbag is the cheap part. It's all the labor that costs and getting that customer to bring their vehicle back.
And the PR of it all.
And the PR, right? So, but the really tricky bit I didn't know until I worked in automotive is that Honda has a choice. They can keep a record of every vehicle and every airbag and the serial number over the years, and also who owns that vehicle 10 years later. That's why you got to register your vehicle with the DMV, so that then the automaker can contact you and say, hey, your airbag is one of the ones from Takata, because they might be buying airbags from 8 different companies. So they need to be able to run you down and say, and run your vehicle down and say, that needs to be replaced.
Wow.
So that type of record keeping is incredibly complex in itself. Just the database of how you track those changes over a few thousand components on a vehicle that's getting built at that speed. And every one of those components can have running changes and serial number changes and updates.
Oh my gosh.
And I think
It's
keeping
wild,
all my tax files from last year is a lot. I mean, the amount of files that they must keep is inordinate.
Right.
And so can you test like one specific component, like, okay, we're going to change the airbags for the vehicle. Do you have to put the airbag in the vehicle and then ship that off for the 30 tests? Or can you just say, just test this airbag? We don't have to make 100 vehicles to test again. Can you test individual components?
Yes.
Oh, okay.
Yeah, you can also do system level testing, right? So if you're changing out one component, you might just test that bolt against the bolt that you used previously and say, it's the same size, it's dimensionally checks out, corrosion test checks out, strength test checks out. It form, fit, and function, it fits the same. Okay, buy it.
Cool.
So that would be a simple one.
Yeah.
A more complicated one would be, I'm going to change the length of this bolt, and it needs to fit with the brackets and the thing it bolts down. So that'd be more of a system level, right? You check it with the associated components. Or if it's a brake system, you would redo brake testing. But you wouldn't necessarily do all the other tests on that vehicle.
Yeah, and is the baseline for like the lifespan of all these different components just based on the car maker, like, hey, we want our stuff to last this long, or does the Department of Transportation say, hey, like mandatory, it has to be safe for this long, or like where do you kind of get your framework by which you work from? That
is really on the manufacturer to like, how do we want our reputation to be? What type of products are we competing against? So there are areas of the vehicle that have certain mandates, especially in cars, like from the insurance side. Because insurance has a big effect on automotive. Like if you have a 5 mile an hour impact and you have to replace the bumper and a couple things, right? If that destroys the value of the whole car, it screws with everything about cars, right? So what that has done over the years is made that insurance companies have forced the automakers to install these bumpers that are kind of semi-disposable on the front of the car, which limits the value of that impact to, $1,000 or $2,000 instead of the whole value of the vehicle.
I wouldn't have expected that car insurance had any sort of impact on the actual manufacturing of the vehicle.
Actually, a lot of the safety testing is driven by the insurance. What's the name of that company? So we've got the National Highway Safety Administration, NHTSA, and then there's the insurance. It's another like national body, but it was created by insurance companies, and it's funded by insurance companies to a large extent. And they actually have created a lot of our crash testing in the U.S. Because when people get injured, the insurance companies are the ones paying for that.
Makes
right?
sense.
So it directly affects their bottom line. They're like, okay, well, we're charging everyone $200 for insurance, but if we can make our costs lower by making vehicles safer, our profit margin goes up. So it's not like altruistic just for safety. It's just like the bottom line is they're paying people's medical bills.
Yeah.
So they want those vehicles to be safer.
I never would have expected insurance to be a positive thing for humanity, but that actually makes a lot of sense, you know?
It's part of the feedback loop, right?
Yeah.
It's one of the feedback loops. The other feedback loop would be like average consumer feedback would be like, I'm not buying a such and such, they're not very safe. Or
people want to buy a Volvo or whatever because they're known for safety.
But our society runs on money, so following that money loop is a very tight way to do it.
That's fascinating. And so are you in direct communication with insurance companies, or do you just kind of like look at like how would someone learn all this? Especially you didn't go to school for it, like on the job. Do you start like picking up and learning random things about the inner workings of, you know, auto manufacturers in relation to insurance? And it's like, this is wildly in depth that I would not. I just thought, hey, I'm going to speak to a mechanical engineer. He probably makes CAD models, and it's like, whoa.
Yeah. No,
this goes deep.
I do that too. This is just all stuff. That's all stuff I've picked up working at Automotive mainly, and some just everyday life stuff, but stuff that seems interesting, relevant.
Yeah, Ooh, that's really cool. And so when you came here today, you biked, and so you obviously align with the Automotive mission in terms of micromobility, moving away from massive 8,000-pound vehicles.
Right.
Do you have like hopes of how Automotive will transform the future of cities or the impact that it'll have? Like, why do you enjoy working with Automotive, and what's the impact that you hope it has on the world?
Like I said, I was always interested in design, and I was always interested in my mobility, actually. I just didn't realize it as clearly. And then I got into a role for designing bicycle trailers with my previous job. And so I was in that bicycle transportation space. And then I got the job at Automotive. And I would really like to see, ultimately, we have to get to a sustainable model as a society at some point, right? Right now we're, you know, burning ourselves right through our, even if climate change didn't matter, we're still going to run out of fuel.
And just pollution.
And pollution.
Yeah.
So pollution, climate change. When I think of pollution, I think of like
clean air,
toxic
water.
pollution.
Yeah.
You know, like that affects livability. And then there's like greenhouse gas pollution.
Yeah, I mean pollution in terms of like, hey, we have less clean water and clean air because of gas burning vehicles. And like the temperature of the climate aside, that is its own separate problem. That seems like everyone would get behind pretty easily.
Right. And I've spent time in China where most of our stuff gets made, and it, you know, if you came to Portland, I saw a video, Portland in the, I think it was in the 50s, you could take a bucket of baby salmon and pour them into the Willamette River in Portland and watch them float to the surface.
Wow.
Right? Because there were so many mills and other factories and so few environmental controls that the river was, and it's still got some pollution issues, but most of those are still there from the past. Like the mud has toxic issues from that period of our history, right? But you have to kind of put it in the context that was right after World War II when we just said, I don't care what it takes, do it.
Yeah.
So we've come a long way.
Absolutely. You say we get a lot of our components from China, but I've been to the ramp and the amp and actually
I
see
didn't mean
like
our components. I meant like all of our stuff, like our everyday things.
Oh, okay. When you say our stuff, I'm like, Automotive, I'm like, I see it all get built
like
here. What could possibly?
You know?
That makes sense, yes.
I guess I'm pushing back on the thing that like people are like, oh, you know, China's doing a lot of polluting. It's like, well, actually we're paying them to make our stuff.
Absolutely. It's a valid component of it.
Yeah.
So nice. So in terms of like what motivates you to continue being a part of the Automotive vision, and just like it's just like, hey, we need to be sustainable.
Yeah, we need to be sustainable, and this is a great place for me to make a contribution to that personal value. It's also a fun place to work, and I feel like Mark has really good values and has always pushed towards. One thing I learned from Mark early on was celebrate your wins now. Don't like wait a whole bunch of time. Like, if you got a win, celebrate it and keep moving. It keeps life fun, and there's always going to be hard times to come as well. So celebrate your wins now and then keep moving forward.
I like it.
I don't know if that's something he said, but it's something I noticed.
That's not one of the core values.
Probably not. But it's it's a good place to work. As long as you're getting your main job done, they are generally very welcoming of you contributing ideas or input in other areas of the company.
That's how the podcast started out. We were doing the rest of social media, making videos, and we're like, we want to spotlight all the incredible, because a big part of why you like working at Automotive is the people make the job. And everyone who I've met at Automotive has just been a spectacular person. I'm like, why aren't we spotlighting these individuals? Like,
yeah, it's really cool.
You know, not a lot of companies you get to hear from quality engineers and like all these little nitty gritty people. So thank you very much for coming on the show, kind of speaking your mind. It'll be exciting to have you back on once we've gone through most of the Eugene folks. Do you have any kind of final thoughts or sayings, or like anyone who's listened to you for a half hour, you know, like important things to your life that you maybe want to share?
I guess back to the sustainability thing. It's all about right sizing, right? If you're using up way more resources, you're taking them from someone else, and ultimately that'll come back to bite you. Mm-hmm. That's just kind of karmic eventually, right?
Beautiful. Well, thank you very much for coming on the show. I appreciate both your time, and I hope you all have a wonderful day. Thanks for tuning in. Bye-bye.